Good evening, students. Hope I'm audible to you. Sorry for delaying the class. Uh, yes, as we started yesterday, your fifth unit, we discussed few of the concepts from your fifth unit. Like we did searching, we discussed linear search, we discussed binary search, and in yesterday's session we also discussed about the basic sorting algorithms. In that we have completed, as you might know, we have completed the bubble sort, and we also discussed the selection sort. So in today's session I'll be focusing only on insertion sort, and along with that we also discussed some of the concepts related to this order of complexity. Okay, some basic concepts related to this order of complexity, and I'll take one more session before we conclude your fifth unit, and in that session I'm going to discuss more about examples on order of complexity. Okay, how to do this order of complexity, we'll discuss some examples. Okay, and in tomorrow's class only we are going to discuss some of the asymptotic notations also for finding the order of complexity. Okay, today I will give basic concepts. With that, we conclude today's session. But tomorrow we'll discuss more in detail about this order of complexity. So let's just not waste the time. I'll start this insertion sort. So as we discussed, sorting is nothing but arranging the elements in an order, in a particular order. Okay. So given a randomly organized list, given a randomly organized array of elements, after applying sorting, what we will get more? We will get a proper sorted array or a proper sorted list we will get. Okay. That is what our intention when we perform the sorting. Okay, so in that we already discussed bubble and selection, and today we are discussing about insertion sort. Okay, yeah, this is what insertion sort thing, and as the approach in this insertion sort, here also we divide the divide the array into two parts. Given array, we are dividing into two parts. One we call it as sorted, and other we call it as unsorted. Yesterday's approach only, same yesterday what we have done now, in that same way we do. Okay, so and every time what we do, we pick one element from the unsorted array and we'll try to push it into the sorted array. And how we do that, I'll explain. Okay, so just remember, every time we pick one element from the unsorted array and we try to push it into the sorted list. Unsorted list నుంచి ఒక ఎలిమెంట్ ని తీసుకుంటాము and sorted list లో పెట్టేస్తాం దాన్ని. Okay, so that here we are not moving the imaginary wall and it will be automatically moved. When you pick one item from here and when you push that item over here, what will happen? Wall will be pushed automatically towards the unsorted list. Okay, so when you pick one element from here and when you push that element into sorted, what will happen? It will decrease the item count, element count in the unsorted list, and it will increase the item count, element count into the sorted list. Okay, that is how we perform this insertion sort, picking one element, pushing into the sorted list. So before we push that element, what we do is we'll check where to keep it. Okay, this is something like I mean while playing cards okay, కార్డ్స్ ఆడతారు కదా, ప్లేయింగ్ కార్డ్స్ ఉంటాయి కదా. కార్డ్స్ ఆడేటప్పుడు వాట్ వి డూ, వి యూజువల్లీ పిక్ వన్ కార్డ్ ఫ్రమ్ ది డెక్ అండ్ వి ట్రై టు put that card into its proper location, isn't it? The cards which we are having in our hand, what we do, the picked card we try to put in its proper location where it will go. Likewise, we'll try to identify and we'll put that card over there itself. So that approach we follow over here. See here, the insertion sort algorithm is one of the most common sorting technique used by card players. So while playing the card players use this technique to arrange the cards into their required order. Okay, whatever order they want the cards to be in their hand, what they will do, whenever they are picking a card, instead of keeping that card here and there, they will put according to their need. They will put mostly in a sorted order. Okay, mostly in a sorted order. So instead, so suppose if we have the cards like one card over here, okay, with A, and another card over here with 2, and you are holding these cards like this, and 4 card here, and suddenly you picked a card and you got that card as card 3, then where you put that card? Yeah, here in this place you will put after A, 2, 3, 4. Likewise, we place this 3 number card in this location. So this is what the insertion sort will do. Whenever we are picking a particular item from the unsorted list, we will check that item and we will identify where that item will fit perfectly into this sorted list. Okay, where that item will fit into this sorted list, will identify the location, and accordingly we push that element into the sorted list. Suppose ikkada meeku 3, 9, okay, and 11, 14 unnai ankondi, and here you got 10. So what we have to do, this 10 you need to pick from here, and where it will go? Neither it will go between 3 and 9, nor it will go between 11 and 14. Exactly, it will go between 9 and 10. So we push this 10 over here. Okay, we'll make the space over here and we'll push this 10 over here. Likewise, we perform. Okay, so in the insertion sort, the list is divided into 2 parts as with previous 2 approaches. One list we call it as sorted list, and the other list we call it as unsorted list. Okay, in each pass, in each sort pass, what we do, we pick the first element of the unsorted sublist. We are picking the first element of the unsorted sublist and transferred it into the sorted sublist by inserting it at a appropriate place. We'll identify the appropriate place where to put that picked element from the unsorted list, and we will put that item into its appropriate place. Likewise, we perform the sorting in insertion sort, because every time we are inserting the element into the unsorted list, we are picking the element and we are inserting the element into the sorted list. That's the reason the name we got, an insertion sort. Okay, hopefully you understood. So here also, how many sort passes it will take before the list gets arranged, in the sense it will take uh, for a list of n elements, it will take n minus 1 sort passes. Okay, for a list of n elements, it will take n minus 1 sort passes before the list gets sorted. Okay, before the list gets sorted. Hopefully you understood the concept of insertion sort. We have an example also for this. Here you can see, this is your original list. This is your original list, and we place here the imaginary wall inside the original list. The imaginary wall will not be placed at the beginning, rather after the first element, because for the first element we no need to perform any kind of sorting. Okay, straight away we will place our imaginary wall after the first element in the original list itself, before even performing the sort pass 1. What I mean to say, okay, before even performing the sort pass 1, we are placing the imaginary list into the original list after the first item. Such way, we are making your sorted list to hold 1 item in the beginning itself, and unsorted list to hold n minus 1 items in the beginning itself. Okay, your sorted list will hold 1 item, and your unsorted list will hold n minus 1 item in the original list itself, before even applying any kind of mechanism in the insertion sort. The imaginary wall itself will be placed after the first item. So then what we do, we pick the first item. Here we picked the first item and we try to locate where it will be, what is its appropriate location. Okay, what is its best location. So obviously we know this 78, it has to come after 23. Okay, to make this sorted list as a sorted list, this 78 has to come after 23. If we put this 78 before 23, the list will not be in sorted order, right? So we have to place this 78 after the 23. So that is what we have done over here. So after the sort pass 1, what we have done, we picked 78 and we placed that 78 after the 23, and your imaginary wall, as you can see, it is automatically got moved one item ahead. Okay, so your now your unsorted list is having one element less, and your sorted list, it is having one item added. Okay, hope you understood this technique. And in the next, after the pass 1, after the sort pass 1, what we are doing, ma, we are picking this 45. As you can see, this arrow, it is showing we are picking this 45, and we clearly can see that this 45 will go between 23 and 78. Okay, between 23 and 78. So that is what we have done. So as we picked it and we placed it between 23 and 78. So now after performing the sort pass 2, what we got? We got 23, 45, 78. 3 items in the sorted list, and same 3 items in unsorted sublist. Okay, hopefully you understood. So then after that, we need to pick this 8. Always, as you can see, we are picking the first item only from the unsorted sublist. We are picking the first item only. So here also we will pick the first item from the unsorted sublist, which is nothing but 8, and we need to identify the appropriate location where it will fit. And as we clearly see that this 8 will be 8's appropriate location will be before 23. So where it will come? Before 23 it will come, and here you got that list. Okay, so 8, 23, 45, 78. Okay, these many items we got. These 4 items we got in sorted list, and unsorted list, again one item less. We got only 2 items now. So after performing sort 3, this is what my situation is. This is what my list is. So now what I have to do, from the unsorted list, one more time we need to pick the 32 and one more element from the beginning of the unsorted list, and we need to identify the appropriate location, and we know that appropriate location will be after 23, before 45. So simply place that 32 over here. So 8, 23, 32, 45, 78. Likewise you got your likewise your list will be after pass 3. Okay, sorry, after pass 4. After pass 4, how my list will be? 8, 23, 32, 45 and 78. And your unsorted list, now it is holding only one element, that is 56. So now, as the last sort pass, pick that 55 and try to locate the appropriate location to put this 55, to push this 55 into the sorted sublist. So we know that this 56 will be after 45 and before 78. So that is what we have done. And here you can see 8, 23, 32, 45, 56, 78. This is how we got the final sorted list. Okay, after pass 5, we are getting the final sorted list. As we can see, we have total 6 items into the list. N is equals to 6. So after how many passes we will get the sorted list? At most n minus 1 passes, that is after at most 5 passes. Okay, 5 passes లో మనకు ఒక సార్టెడ్ సబ్ లిస్ట్ వచ్చేసింది, సారీ సార్టెడ్ లిస్ట్ వచ్చేసింది, as you can see here. So this is how we perform the insertion sort algorithm, insertion sort example. Okay, hope it is clear. So this theory, this diagram, this example you have to remember for this insertion sort concept along with the example program. So this is the flow chart, and here this current will act like an imaginary wall between the sorted sublist and unsorted sublist, and every time using this logic we are picking one item from the beginning of the unsorted list, and we are identifying the best location or appropriate location in the sorted sublist, and we are placing that item into the sorted sublist. Okay, so yeah, this is the flow chart, and after this we have the code. As you can see, the code, it is not having any swap because we are not performing any swapping now. We are just picking the item from the top of the unsorted list and we are placing it into the sorted sublist. So no need to write the swap operation, swap function over here. So we got only two functions to write now. One is insertion sort function, other one is the print array function. And this thing, the main function, it is same like your bubble sort, selection sort. Only thing which changes over here is this one, insertion sort function call. Previously it was bubble sort, after that selection sort, and but now it is insertion sort. This thing only changes. Rest of all, it is same like your previous examples. Okay, and your print array function also, it is same like your other two sorting techniques. Nothing is changed here. As you can see here, our print array function, it is same like your bubble sort, selection sort, the same we are using here also. Only this function we need to work out. ఓకే, ఈ పర్టికులర్ ఫంక్షన్ గురించే మనం వర్రీ అవ్వాలి. ఈ పర్టికులర్ ఫంక్షన్ మనకు తెలియాలి. అండ్ దిస్ ఫంక్షన్ ఆల్సో సేమ్ లైక్ అదర్ సార్టింగ్ టెక్నిక్. మెయిన్ ఫంక్షన్ ఆల్సో సేమ్ లైక్ అదర్ సార్టింగ్ techniques. Okay, so this function again here, current will act like the imaginary wall between sorted sublist and unsorted sublist, and this temp is nothing but picking the first item from the unsorted sublist. Will pick the first item into this temp variable, and this walk will act like an walkthrough into the unsorted sublist. Okay, so using this logic, we'll identify the appropriate location where to put this temp. And once we got that appropriate location, as you can see here, list of walk plus 1. This is nothing but your appropriate location. In that place, we are keeping the picked item from the unsorted sublist. So that is how this logic will work. So quickly, we demonstrate this in the Dev CPP. Okay, let me just write the code. Okay, then we need to write our insertion sort. It will take array and size. Then we need to write print array. It will also take integer array and size of the array. Okay, then you write your main. Okay, now what we have to create the list of equals to, put some items into it of your wish, 64, 56, 32, okay, 98, 8, 5, 6, okay, 23. Likewise, some random items I kept into my list. Then we need to identify the size. I told you now how we identify the size. Size of whole array, whole list, size of whole list divide with size of individual item, any individual item, list of 0. Okay, this will give you the size. Okay, once we have the size, call the insertion sort with the list with the size. Okay, once you got the insertion sort, now it is the time to print the list. Okay, so sorted list, in bracket you write what approach you used. So here we have used insertion sort, so that insertion sort I'm writing. Okay, next is print array function call cheyali. We need to call the print array function with list and int. Okay, so immediately return 0. Okay, come down and define. First I'm defining my print array. Okay, it is easy to define, so I'm defining my print array, receive same list and receive same size. Okay, sorry. So my keyboard, it is giving somewhat issue. Okay, now uh, just take one temporary variable for running the loop because we are printing the array. So I equals to 0, I must be less than size I plus plus. Come down and printf percentile d space ampersand, not ampersand, list of I. That's it. This will print the array. Okay, let me just, yeah, print array only 3 lines. That's it. Now we need to write the definition for insertion sort of receive the list, comma receive the size. Okay, receive the list, receive the size. Now you create your variables. First is imaginary wall, walker, temporary. Okay, then, yeah, start the imaginary wall. Current equals to 1. Current must be less than size and current plus plus. Okay, come down and select the temporary, I mean, in from the unsorted list we need to select the first item. So list of current. Okay, as you can see, wall we started from 1 ma, not from 0, and whatever item we have at 1, that item only we are selecting. Okay, then walk will become current minus 1. Okay, take one while loop. Walk must be greater than or equals to 0, and list of walk, it should be greater than temp. It should be greater than temp. Come down and then list of walk plus 1 equals to list of walk. Okay, then walk equals to walk minus 1. Okay, come out of the loop, while loop, then list of walk plus 1 equals to temp. Okay, hopefully this will save this. Okay, so now just run it. Here not int, here size. There is some mistake I have done. Just copy this, paste here, paste here. Conflicting type, insertion sort. Yeah, here we have to receive it like an array. This was the error. We have to receive it like an array because we are passing the array. Okay. Yeah, as you can see, the compilation, it is successful. Run it, and as you can see, I'm getting this list in the sorted order. Using insertion sort, I'm performing the sorting. So I got this list in sorted order. Complete list, it is giving me in sorted order. Okay. So as simple as it is. So with this, we have concluded all the sorting techniques, all the three sorting techniques, what we discussed, what we have in the fifth unit to be discussed. We started with searching techniques, two searching techniques, linear search, binary search, we have completed. Then two sorting techniques, three sorting techniques, bubble sort, selection sort, insertion sort. We discussed all the three sorting techniques, two searching techniques. With that, we conclude searching and sorting. And we have an important concept to be discussed in your fifth unit, that is order of complexity. Order of complexity that we will start now. Okay. So basic concepts in order of complexity we will see first. Then we will go to the examples, how to do this calculation of order of complexity in tomorrow's session. Okay. So here you have basic concepts for order of complexity. So we need to discuss some of the basic terminology before we get into the order of complexity thing. So we know that the algorithm what we have discussed in your first class itself, it is the fundamental thing to computer science, because whatever programs we write, whatever softwares we develop, whatever IT projects we do, for everything a kind of analysis, a kind of design must be needed. Okay. And we straight away, whatever problem statement comes to us, we will not go for program development straight away. ప్రాబ్లం స్టేట్మెంట్ వచ్చిందంటే మనం స్ట్రైట్ గా కోడ్ రాయడం స్టార్ట్ చేయమమ్మా. ఓకే, బిఫోర్ వి రైట్ ది కోడ్, బిఫోర్ వి డూ కోడింగ్, it has to go through, I mean the problem statement has to go through different phases. Okay, so about those phases and all we will discuss more in detail. You have specific subjects for those type of phases to be discussed. There you will discuss, but here the algorithm thing, okay, as it is related to very basic, very fundamental topic, we need to have some clear understanding about what this algorithm is and why it is having a crucial role in program development. Okay, so we know algorithms we have for many common problems like and designing an efficient algorithm. See here, we need to we must understand this term. We are saying efficient algorithm. Okay, efficient algorithm we are saying, and designing an efficient algorithm plays a crucial role in developing large scale computer applications. Okay, applications is nothing but writing programs only, because application when we design, application when we create, what we exactly do means we write programs only. Okay, సో ఎఫిషియంట్ అల్గారిథమ్స్ ని మనం ఒకవేళ ఫ్రేమ్ చేస్తే మన అప్లికేషన్ కూడా ఎఫిషియంట్ గా ఉండే ఛాన్సెస్ ఉంటాయి. ఓకే, సో దట్స్ ద రీజన్ డిజైనింగ్ ఎఫిషియంట్ అల్గారిథమ్స్, ఇట్ ప్లేస్ అ క్రూషియల్ రోల్ ఇన్ డెవలపింగ్ ది large scale computer application. Okay, so we defined the term algorithm over here already. We discussed about this algorithm definition in our earlier classes as well. It is nothing but a step-by-step procedure. Your algorithm, it is nothing but it is a step-by-step procedure for solving a computational problem. Okay, because as we deal with computations, okay, as we deal with computers, so we use this term to define our algorithm, computational problem, for solving a computational problem. Okay, so which is nothing but a set of instructions to be executed, because we write programs, those program instructions only we will put in the form of algorithm, and when that algorithm converted into a computer program, how it looks like, in the sense it will have, that program will have a set of instructions to be executed in a certain order. Okay, to get the desired output. మనం అల్గారిథం లో ఏదైతే స్టెప్స్ ని రాస్తామో ఆ స్టెప్స్ నే మనం ప్రోగ్రామ్ లో ఇన్స్ట్రక్షన్స్ గా కన్వర్ట్ చేస్తాం. వి కాల్ ఇట్ యాజ్ స్టెప్స్ ఇన్ అవర్ అల్గోరిథం అండ్ వి కాల్ ఇట్ యాజ్ ఇన్స్ట్రక్షన్స్ ఇన్ అవర్ కంప్యూటర్ program. Okay, you must understand that difference. Step by step we are saying for the algorithm, step by step procedure we are saying, but whereas a computer program, it will have a set of instructions executed in a certain order. Okay, your computer program is nothing but a set of instructions to be executed in a certain order to get the desired output. Okay, so yeah, here you can see a program is also a step-by-step procedure for solving a problem. Okay, at design time, we write these steps for solving the given problem. This is not the program. I mean, at the design stage, whatever steps we write, we call it as an algorithm. We'll not call it as a program. Okay, because whatever order of complexity we do now, order of complexity, there are two things. One is analysis and another one is experiment. Analysis and experiment. Soon you will understand these two terms. See, experiment, what we do, it is on the program. Experiment మనం దేంతో చేస్తాం, program తో చేస్తాం. Analysis whatever we do na, that is with the help of algorithm we do. Okay, through algorithm we can do analysis and through program we can do experiment, because we will have the program handy and we have the compilers and we have the runners to execute the program. But the same thing is not true in case of an algorithm. It is just the steps written on a paper. We cannot code the algorithm into a computer and we cannot expect the algorithm to give the output by consuming the computational resources, isn't it? By consuming your computer, by consuming your memory, your algorithm can't give the output. But whereas a program, it is an experiment entity. You can execute the program and you can get the output from it. It will consume the computational resources. Your program will consume the computational resources, and moreover, your program we code into a computer. Okay, by using some text editor, by using some compiler, IDE, we code this program into our computer. Okay, hopefully you understood. So while writing the algorithm, we don't follow any syntax. Your algorithm, it is syntax free. Okay, it is just English like statements without using any syntax. Okay, this will not be written in a computer and on a paper. We can write the algorithm on a paper and we cannot code the algorithm into a computer. Even if you code, it is of no use, because you don't get any output from it. Okay, hopefully you understood the basic necessity of an algorithm. Okay, so yeah, algorithms are generally created independent of any programming language. We don't use any programming language or any language, any specific language while designing the algorithms. Okay, while creating or while designing the algorithms. To write algorithms, any natural language can be used. Our human languages, natural languages are nothing but human languages, and we use only human languages with simple mathematical instructions we set, with simple mathematical understanding we set. Okay, so what language we use when designing an algorithm? Mostly in our consideration, we use English language only while designing the algorithm. Okay, so as it is syntax free, your algorithm, as it is just the step by step statements, step by step procedure. So those step by step procedures, step by step statements can be converted into any of the programming language. Okay, అల్గారిథం రాసిన తర్వాత అల్గారిథం ని ఒక పర్టికులర్ ప్రోగ్రామింగ్ లాంగ్వేజ్ లోనే కన్వర్ట్ చేయొచ్చు అనే కాన్సెప్ట్ ఉండదమ్మా. యూ హ్యావ్ రిటన్ ది అల్గారిథం అండ్ దట్ అల్గారిథం కెన్ బి కన్వర్టెడ్ ఇన్ any of the programming languages. So that's the reason the last statement you read here, an algorithm can be implemented in more than one programming language. There is no programming language barrier while converting the algorithm into a program. You can use any programming language. You can use C, you can use C++, Java, Perl, anything you can use. Okay, hopefully you understood. So what do you mean by performance analysis, Ma? What do you mean by order of complexity or order of performance analysis? Okay. So the most important attribute of a program is its correctness. Okay, because when we are writing the program, it should be correct. Okay, it should be unambiguous and it should be correct. Okay, this is one of the important property which we expect from a computer program. Okay, so and suppose you are writing your program for some specific task, and if your program is not performing according to the task, okay, according to the intended task, you're writing an algorithm, you're writing a program, you're writing a computer program, and your computer program is not performing as per your requirement, as per your desire, then what will happen, ma? That program is of no use, isn't it? You have written the program and it is not performing according to your requirement, in the sense it is of no use. Okay, so uh, sometimes what will happen, even if the computer program is performing as per your requirement, but if it is taking more computer memory, okay, syntactically your program is correct and it is giving whatever output you want. Okay, there are two conditions, ma, here we are discussing. First thing is completely program is wrong and it is not giving any output, or it is not giving the output according to your requirement, in the sense we will say that computer program is is of no use. Okay, there is another scenario. Suppose if your computer program is correct, syntactically correct, and it is also giving the output, but at what cost, ma? It is taking more computer memory and it is taking too long to execute. Okay, too long to execute, where the user is getting what we call exhausted. Okay, the user, he don't want to wait that long. Okay, so if your program is behaving in such a way, again it is of no use, ma. Even though it is performing good, sorry, even though it is giving correct result, correct outcome, even though it is syntactically correct, if it is consuming more computational resources, that is nothing but more computer memory and more time to execute, in the sense again it is of no use. Definitely your end user will get exhausted and he will not show any interest in your computer program. So there comes the word, okay, the performance of a program or program performance. Okay, it is used to refer the memory and time requirement of a program. When we say performance analysis or performance of a computer program, okay, uh, what uh, uh, what parameters we are looking into, ma? We are looking into the amount of memory your program is consuming and the amount of time your program is taking for execution. These two parameters only we discuss. There are a lot of other parameters also available. Hopefully we will see in our next slide. So for now, you just remember, whenever we are saying program performance, our concern will be, the first one is memory and the second one is time. Okay, so program performance means, yeah, as I said, na, the amount of computer memory and the time needed to run a program. The last statement will straight away telling that one. See, whenever we are saying program performance, it means the amount of memory the computer program is consuming and the amount of time the computer program is taking to execute. సో దిస్ ఇస్ వాట్, మా పర్ఫార్మెన్స్ అనాలిసిస్ అంటే ఈ టూ థింగ్స్ నే మనం ఎక్కువగా గుర్తుపెట్టుకోవాలి. వన్ ఈజ్ మెమరీ అండ్ ది అదర్ వన్ ఈజ్ టైం. ఓకే, సో మెమరీ అనాలిసిస్, time analysis we have to do for every algorithm to tell whether it is a good performing algorithm or whether it is a bad performing algorithm. Hopefully you understood, ma. ఓకే, ఈ క్రైటీరియా ఇక్కడ ఏదైతే మనం టాపిక్స్ డిస్కస్ చేస్తున్నామో అమ్మ, ఫ్యూచర్ లో మీకు డిఫరెంట్ సబ్జెక్ట్స్ ఉంటాయి. లైక్ డేటా స్ట్రక్చర్స్ లో కూడా ఈ టాపిక్ వస్తుంది మీకు, టైమ్ అండ్ స్పేస్ కాంప్లెక్సిటీ. అండ్ మీకు ఇంకొక సబ్జెక్ట్ ఉంటుంది డా అని, డిజైన్ అండ్ అనాలిసిస్ ఆఫ్ అల్గారిథమ్స్ అని ఉంటుంది. అక్కడ కూడా ఈ టాపిక్ మీకు హెల్ప్ఫుల్ అవుతుంది. ఏదైతే బేసిక్స్ మనం ఇక్కడ నేర్చుకుంటున్నామో ఈ బేసిక్స్ మీకు అక్కడ కూడా హెల్ప్ఫుల్ అవుతాయి. అండ్ యువర్ కంపైలర్ డిజైన్ దెర్ ఇస్ అనదర్ టాపిక్, అనదర్ సబ్జెక్ట్ విత్ నేమ్ ఫ్లాట్, ఫార్మర్ లాంగ్వేజ్ అండ్ అటామెటా థియరీ. ఫ్లాట్ అంటారు దాన్ని. సో ఆ సబ్జెక్ట్ లో కూడా ఈ పర్ఫార్మెన్స్ అనాలిసిస్ మెజర్ హెల్ప్ఫుల్ అవుతుంది. సో డిఫరెంట్ సబ్జెక్ట్స్ ఉన్నాయి, దెర్ ఆర్ లాట్ ఆఫ్ డిఫరెంట్ సబ్జెక్ట్స్ ఇన్ యువర్ డిస్క్రీట్ మ్యాథ్స్ ఆల్సో వి విల్ యూజ్ దిస్ పర్ఫార్మెన్స్ అనాలిసిస్. in 2-1 you are going to study about discrete maths, there also we need this performance analysis. Okay, in many different subjects these basics are going to help you, ma. Okay, so simply once again I'm repeating what I mean by performance analysis, ma, or program performance. Simply I need to check how much amount of computer memory it is consuming and how much amount of time it is taking to execute. These two things only I need to test. Okay, so yeah, we have different approaches, ma, actually to determine the program performance. As I said, now one is analytical method and the other one is experimental method. Analytical and experimental. Okay, uh, analytical, what we do, ma, we use some analytical methods to analyze the performance. Will not what we call will not apply it, ఆ పర్టిక్యులర్ స్ట్రాటజీని, ఆ పర్టిక్యులర్ లాజిక్ ని ఏదైతే మనం అల్గోరిథంలో రాస్తామో ఆ లాజిక్ ని మనం అప్లై చెయ్యము. అప్లై చేయకుండా సింప్లీ ఆ లాజిక్ లో రాసిన స్టేట్మెంట్స్ ని చూసి మనం ఎంత స్పేస్ కన్జ్యూమ్ అవుతుంది, ఎంత టైం కన్జ్యూమ్ అవుతుంది అనే పారామీటర్స్ ని మనం అనలైజ్ చేస్తాం. సో ఆ అప్రోచ్ నే మనం, దట్ టైప్ ఆఫ్ అప్రోచ్ ఓన్లీ వి కాల్ ఇట్ యాజ్ అనలిటికల్ మెథడ్. అనలిటికల్ మెథడ్ ఇన్ ద సెన్స్ వి విల్ నాట్ అప్లై ది లాజిక్, రాదర్ వి అనలైజ్ ది లాజిక్. But experimental approach, second one, experimental approach, what we do here, we convert the algorithm. Simply to say, experimental approach ఎలా ఉంటుందంటే అల్గోరిథం ని ప్రోగ్రామ్ లోకి కన్వర్ట్ చేయాలి, ఆ ప్రోగ్రామ్ ని ఎక్స్పెరిమెంట్ గా తీసుకోవాలి, అంటే రన్ చేసి చూడాలి ఎంత టైం తీసుకుంటుంది, ఎంత మెమరీ కన్జ్యూమ్ చేస్తుంది అనే దాన్ని రన్ చేసి చూడాలి. దట్ అప్రోచ్ వి కాల్ ఇట్ యాజ్ ఎక్స్పెరిమెంటల్ మెథడ్. ఓకే, అండ్ హియర్ in our what we call performance analysis, we will not do experimental approach, will not go for experimental approach. అంటే ఇచ్చిన అల్గోరిథం ని, ఇచ్చిన కోడ్ ని మనం ప్రోగ్రామ్ గా కన్వర్ట్ చేసి అది ఎంత మెమరీ కన్జ్యూమ్ చేస్తుంది, ఎంత టైం తీసుకుంటుంది అనే పారామీటర్స్ ని మనం అనలైజ్ చెయ్యమమ్మా. స్ట్రైట్ అవే వి డూ analytical method only. Without converting the algorithm into a program, we will go in an analytical approach. Okay, so here we use the analytical method only to analyze the performance of an algorithm. Okay, so this is what you need to remember. Okay, so quickly, yeah, I said now only two measures, only two things we need to focus whenever we are talking about the performance of an algorithm or performance of a program. One is the space complexity and the other one is the time complexity. So as I said earlier, space complexity is nothing but the amount of space, amount of memory. Space is nothing but memory, ma. Okay, the space complexity of a program is the amount of memory needed to the program for completion. Okay, ఎంతైతే టైం, ఎంతైతే స్పేస్, ఎంతైతే మెమరీ ఆ ప్రోగ్రామ్ ని ఎగ్జిక్యూట్ చేయడానికి అవసరం పడుతుందో దాన్నే మనం స్పేస్ కాంప్లెక్సిటీ అంటాం. దెన్ టైం కాంప్లెక్సిటీ, ఇట్ ఈస్ ఆల్సో వెరీ సింపుల్. టైం కాంప్లెక్సిటీ ఆఫ్ అ ప్రోగ్రామ్ ఈస్ నథింగ్ బట్ ది అమౌంట్ ఆఫ్ టైం. Okay, here time in the sense computer time, the amount of computer time the program needs to complete the execution process. That is what the time complexity analysis. Okay, time complexity ante the amount of time needed for executing a computer program, and space complexity is nothing but the amount of memory needed for executing or for completing a program, a computer program. Okay, so these two terms, టైం కాంప్లెక్సిటీ అండ్ స్పేస్ కాంప్లెక్సిటీ. సో ఈ అనాలిసిస్ చేస్తామమ్మా. జనరల్ గా మనం స్పేస్ కాంప్లెక్సిటీని ఎస్ ఆఫ్ ఎన్ అంటాము అండ్ టైం కాంప్లెక్సిటీని ఎఫ్ ఆఫ్ ఎన్ అంటాము. సో దీస్ టూ మెజర్స్ వి నీడ్ టు ఐడెంటిఫై. ఓకే, స్పేస్ ఎంత అవసరం పడుతుంది ఒక ప్రోగ్రామ్ కి, టైం ఎంత అవసరం పడుతుంది అనే దాన్నే మనం మెజర్ చేస్తాం. ఓకే, చాలా ఐ మీన్ sometimes it may look illogical to you. Why we are doing this type of analysis, sometimes it may look illogical to you, but it is worthy. అంటే ఏదైతే ప్రాసెస్ మనం ఫాలో అవుతామో, ఏదైతే అప్రోచ్ మనం ఫాలో అవుతామో, ఎలాగైతే మనం టైమ్ అండ్ స్పేస్ కాంప్లెక్సిటీ అనాలిసిస్ చేస్తామో, దట్ అప్రోచ్ ఇట్ ఈస్ వెరీ మచ్ యూస్ఫుల్, బిలీవ్ మీ. ఓకే, సో yeah, how to analyze an algorithm. So the criteria for analyzing an algorithm, first is time. Okay, the algorithm must be time efficient. When we are doing analysis, performance analysis, what we say, the algorithm must be time efficient. Time efficient ante enti, it must be faster in execution. It should take less time, then only we call it as an time efficient algorithm. Okay, in the analysis process, the time taken by an algorithm is measured, whether the algorithm is lengthy and time consuming, or it is smaller or and faster. Okay, lengthy ante more number of instructions unte, obviously it will consume more time, and if it is having less number of instructions, smaller in size, less number of lines of code, then obviously it will be faster. Okay, the time consumed by the algorithm will be in the form of function, time function antaru danni, already I told na, we will call it as f of n. Okay, and not in the form of watch or clock. Don't you think that time ante manaku algorithm 2 seconds తీసుకుంటుంది, 3 seconds తీసుకుంటుంది అని మనకు మన రొటీన్ లైఫ్ లో ఏదైతే వాచ్, ఏదైతే క్లాక్ టైం మనం యూజ్ చేస్తామో అలాంటి వాటిలో రాదు. ఇట్ విల్ కమ్ ఇన్ యూనిట్స్, ఇన్ ద ఫార్మ్ ఆఫ్ యూనిట్స్. ఓకే, యూనిట్స్ లో వస్తుంది. యూనిట్స్ అంటే ఇట్ ఈస్ అన్ అన్డిసైడెడ్ యూనిట్. ఓకే, సో సపోజ్ ఇప్పుడు ఎఫ్ ఆఫ్ ఎన్ ఫర్ అన్ అల్గోరిథం 4 అని వచ్చింది అనుకోండి, ఇట్ ఈస్ అ కాన్స్టెంట్. ఓకే, అండ్ ఈ కాన్స్టెంట్ ని మెజర్ చేయడానికి అగైన్ వీ హ్యావ్ అసిమ్టోటిక్ నొటేషన్స్. ఓకే, బిగో నొటేషన్ అని, ఒమేగా నొటేషన్ అని, తీటా నొటేషన్ అని డీటెయిల్ గా మనం డిస్కస్ చేస్తాం ఇన్ అవర్ టుమారోస్ క్లాస్. ఓకే, బిగో, ఒమేగా, తీటా నొటేషన్స్ యూజ్ చేసి ఈ కాన్స్టెంట్ ని మనం ఒక ఆర్డర్ లో కన్వర్ట్ చేస్తాం, ఆర్డర్ ఆఫ్ కాంప్లెక్సిటీలో కన్వర్ట్ చేస్తాం, బికాస్ దట్ ఈస్ వాట్ అవర్ కాన్సెప్ట్. వీ నీడ్ టు కన్వర్ట్ దిస్ కాన్స్టెంట్, ఆర్ వీ నీడ్ టు కన్వర్ట్ ది time space into some order. Okay, how much it is taking. Likewise, then space, the algorithm will be converted into a program and going to be executed on a computer. One has to know how much memory space it is going to consume during its execution. So if you convert the algorithm into a program and execute that program on a computer, how much memory it will consume or how much memory it will take for its execution. That is what the space requirement or space criteria. Okay, next we also have network consumption. See, suppose you are writing an algorithm, and that algorithm it is dependent on internet. Okay, that program it is dependent on internet. ఏదైనా చాట్ అప్లికేషన్ రాస్తున్నారు అనుకోండి, లేదా ఏదైనా మెసేజింగ్, టెక్స్ట్ మెసేజింగ్ అప్లికేషన్, లేదా వాట్సాప్ కైండ్ ఆఫ్ అప్లికేషన్ మీరు రాస్తున్నారు. ఓకే, సోషల్ మీడియా అప్లికేషన్ మీరు రాస్తున్నారు. సో ఆబ్వియస్లీ ఇట్ విల్ కన్స్యూమ్ సర్ some internet, isn't it? Some network consumption it will do. So that type of network consumption, how effectively it is doing, that is what network consumption criteria. So this analysis we will not do. Network consumption analysis we will not do. We will go in a basic approach and we'll do only space and time complexity analysis. Okay. Then power consumption. How much power is nothing but your electricity. How much electricity it is consuming. It is also one of the important criterion. Okay. Suppose if you are executing your application in a miniature device, in a handheld device, your mobile phones, your tablets, your tablets, your laptops, all they will have some power constrained environment. All these are power constrained environment. Battery matters over there. If your application, if it is consuming more battery, obviously the user will uninstall or user will not use. Okay, so that's why your application, your algorithm, it should be power consumption efficient. It should consume less power for execution. Okay, then finally the CPU registers. So inside our CPU, when we discussed about different forms of memory, there we discussed about CPU registers, and our algorithm must consume less amount of CPU registers. Okay, then only we consider it as an effective algorithm. Okay, So 5 criteria discuss cheshamamma. First one is time, second is space, network consumption, then power consumption, and finally the CPU registers. And in these 5 criteria we analyze only the first two, time and space. Once again I am telling you, we analyze only two, time and space. And I told you, time function f of n, space function s of n. Okay, so measuring time and space complexity. So this is what the concept, how we measure the time taken by an algorithm, and how we measure the space taken by an algorithm. Okay, so time analysis, how we do, in the sense, every simple statement, if it is not in a loop, and if it is not nested, if it is not recursive, ఓకే, ఇలాంటి స్టేట్మెంట్ కానప్పుడు, ఇఫ్ ఇట్ ఈస్ నాట్ కండిషనల్, ఇఫ్ ఇట్ ఈస్ నాట్ ఐటరేటివ్, ఇఫ్ ఇట్ ఈస్ నాట్ రికర్సివ్, ఒక నార్మల్ స్టేట్మెంట్ రాశాము అంటే ఇలా, ఏ ఈజ్ ఈక్వల్స్ టు బి ప్లస్ సి అని రాశాము, ఒక నార్మల్ స్టేట్మెంట్ అమ్మా. సో దిస్ టైప్ ఆఫ్ స్టేట్మెంట్స్, as long as they are not inside loop, inside conditional statements, inside recursion, okay, they will take how much time? Only 1 unit of time they will take. We assume it will take only 1 unit of time. When I'm saying a simple statement, a normal statement, a sequential statement, no repetition, no what we call no decision making, no repetition, nothing. Okay, if it is a simple statement, how many units of time it will consume? It will take only 1 unit of time. You need to remember this thing. Okay, so if an algorithm is calling or using another algorithm, so this is function call or recursion. If you have like that type of statements in your algorithm, ఓకే, ఒక ఫంక్షన్ కాల్ ఉంది లేదా ఒక రికర్సివ్ కాల్ ఉంది, అలాంటి కేసులో మనం ఏం చేయాలి? ఆ కాల్డ్ ఫంక్షన్ ని అనలైజ్ చేయాలి, కాల్డ్ అల్గోరిథం ని అనలైజ్ చేయాలి, లేదా రికర్షన్ ని అనలైజ్ చేయాలి. ఓకే, సో దేర్ ద టైమ్ విల్ చేంజ్ మా. ఓకే, అలాంటి ఎగ్జాంపుల్స్ కూడా మనం ప్రాక్టీస్ చేస్తాం. దేర్ ఐ విల్ టెల్ యూ హౌ టు అనలైజ్ అ లూప్, హౌ టు అనలైజ్ అ కండిషనల్ స్టేట్మెంట్, హౌ టు అనలైజ్ అ ఫంక్షన్. ఓకే, లైక్ వైజ్. సో దిస్ ఇస్ వాట్ అబౌట్ టైమ్ అనాలిసిస్. సింపుల్ స్టేట్మెంట్ అయితే 1 unit, నెస్టెడ్ అయినా, ఫంక్షన్ కాల్ అయినా, లూప్ అయినా కంపల్సరీగా ఆ 1 unit అనేది చేంజ్ అవుతుంది. 1 unit ఉండదు అక్కడ, సమ్ డిఫరెంట్ amount of time it will consume. Okay, we do analysis when it comes in our discussion, we do analysis. Okay, then space analysis, every simple variable, just oka variable create chesaru in your algorithm, you have created declare a and rasharu. So this variable will consume 1 unit of memory, or one word antaru ikkada. Okay, not unit, one word of memory. Okay, every simple variable in your algorithm will consume 1 word of memory. So if you have a complex variable ante oka array undi leda oka structure kind of thing undi, so obviously it will consume more. Okay, just give me 1 minute ma. Hello sir, good evening. Sir, I've received. Thank you, sir. Thank you. Okay, sir. Thank you, sir. Okay, ma. So space analysis, as I said, now every every simple variable will take 1 word of memory, and every complex variable, okay, every complex variable like your array, it depends on how many elements you have in that array. Okay, suppose if it is having 10 elements, then 10 words of memory. Okay, n elements, n words of memory. Likewise, we will consider. Okay, when we do space and time complexity analysis, there you will understand more in detail. ఒక అల్గోరిథం ని ఎగ్జాంపుల్ గా తీసుకొని మనం టైమ్ అనాలిసిస్, స్పేస్ అనాలిసిస్ చేస్తాము, పర్ఫార్మెన్స్ మెజర్ చేస్తాము. There you will understand, okay, the importance of performance analysis. So here we have one simple example, as you can see, for swap function. Okay, for swapping two variables a and b, I'm using this function. So obviously we know we need a temporary variable to swap two what we call variables. So temp, first we put the a value into temp, then b value into a, then temp value into b. So as you can see, how many instructions we have, how many steps we have in this algorithm? Only three simple steps we have. This is step 1, it is consuming 1 unit of time. Step 2, it is also consuming 1 unit of time. Step 3, it is also consuming 1 unit of time. So our uh, time function, what we got, ma? We got 3 units. Time function, we got 3 units, and it is a constant. It is a constant, so your order will be 1, ma. Order of complexity will be 1. Okay. So why this big O of 1 we have written over here, tomorrow we will understand. So whenever we get a constant, we'll analyze it as order of 1. Okay, we call it as order of 1. Whenever there is a constant, we get constant units of time we will get for our time function, the order will be order of 1, like that you remember. So say space analysis, here you can see we have three different variables we are using: a, b, temp. So a is a normal variable, so one word of memory. Okay, b is a normal variable, again one more word of memory. Temp is a normal variable, again one word of memory. Okay, so three overall, how many words? Three words. Again it is a constant. Okay, for space function we got a constant number of words. So what will be the order? As long as it is a constant, our order will be 1, order of 1. We consider it as order of 1 complexity. Okay, hope you understood, ma. More examples we will do in tomorrow's session. More complex examples we will do in tomorrow's session. With that, we will have some clear understanding about this performance analysis. Okay, how we do performance analysis, or how we calculate this order of complexity more in detail, we will try to understand in tomorrow's session. Okay, with this understanding, I'm concluding today's session. Thank you very much, students.